Hello, my name is Danny, and this is my molecular orbital MO alternate assignment for my chemistry course at MUN, which is Memorial University of Newfoundland in Canada. Chemical bonding is a foundation to chemistry. Three important theories in chemical bonding are Lewis theory, valence bond theory, and molecular orbital, abbreviated MO theory. Lewis theory is a simple model in chemical bonding which uses diagrams that represent bonds between atoms as pairs of dots or lines. In Lewis theory, atoms bond together to obtain octets or 8 valence electrons. Valence bond theory is an advanced model in chemical bonding whereby electrons reside in quantum mechanical orbitals localized on individual atoms, which are a hybridized mixture of standard atomic orbitals. When these orbitals overlap, chemical bonds result. Molecular orbital MO theory is also an advanced model of chemical bonding, whereby electrons reside in molecular orbitals delocalized over the entire molecule. In the most basic version, the molecular orbitals are simply linear combinations of atomic orbitals. So I do have my laser pointer. I always like to use a laser pointer. I just, instead of a ruler or a stick or that type of thing. So I hope that you guys can follow the little red dot. I'll try to make it so that you can follow it or just make things easier. Okay. Okay. This is molecular orbital MO energy diagram for H2. Okay. One of the molecular orbitals for H2 which would be this one, is just an equally weighted sum of the 1s orbital from one atom and the 1s orbital from the other. This molecular orbital is named sigma 1s. The sigma 1s orbital is lower in energy than either of the two 1s atomic orbitals from which it was formed. Because of this, it is called a bonding orbital. When electrons occupy bonding molecular orbitals, the energy of the electrons is lower than it would be if they were occupying atomic orbitals. Okay, so now I'm going to talk about this one right here. So it's the molecular orbital, which is on the top. It's called the antibonding molecular orbital. This molecular orbital is named asterisk sigma 1s. The asterisk represents that this orbital is an antibonding orbital. Antibonding orbitals are the result of orbitals with different phases, causing destructive interference between them, resulting in a node between the two atoms. Electrons in antibonding orbitals have higher energies than they did in their atomic orbitals, so tend to raise the energy of the system relative to the unbonded atoms. This molecular orbital diagram indicates that two hydrogen atoms can lower their overall energy by forming H2 because the electrons can move from higher energy atomic orbitals into the lower energy sigma 1s bonding molecular orbital. So, in other words, if we look at this diagram here and we see the electrons, right? So here's one electron and here's another electron. Now these electrons, as you can see by the diagram, they can either go to the bonding molecular orbital, which is a lower energy, or they could go to the antibonding molecular orbital, which is higher energy. But the rule says that the lower energy molecular orbitals fill up first before the higher energy molecular orbitals. So that's why both of these electrons fill into this one here, which is the bonding molecular orbital, because it has a lower energy than this one, which has a higher energy. Because like I said, the lower energy molecular orbital fills before the higher energy molecular orbitals. So the next topic we are going to be talking about bond order. So, okay. So, as I just wrote down here, bond order is or equals the number of electrons in bonding molecular orbitals minus the number of electrons in antibonding molecular orbitals, all that divided by 2. So, if we look at again, we're still using the H2. So if we want to know the H2 bond order, so if we need the number of electrons in the bonding molecular orbitals, we just look at our diagram and we see there's 2 electrons here. Minus, so this says the number of electrons in antibonding molecular orbitals, and we look at here and there's no electrons there, 0. All that divided by 2 equals 2 over 2 equals 1. So the H2 bond order is 1. So H2's bond order of 1 means that a single bond will form between the 2 hydrogen atoms. If we got a positive bond order, this means that there are more electrons in bonding molecular orbitals than in antibonding molecular orbitals. So the electrons will have lower energy than they did in the orbitals of the isolated atoms, and the formation of a chemical bond will happen. Basically, the higher that the bond order is, the stronger the bond will be. A 0 or negative bond order indicates that a bond won't form between the atoms. And that's all the video is for today. Thanks for watching. Please press subscribe. Please press all notifications. Goodbye.